Hello again. So, we have our final challenging geometry, 3D geometry problem for this lesson. Adam the ant is now on this cylinder. He wishes to walk along the curved surface of the cylinder to point B, where BC is a height of the cylinder, and C is on the top base such that AC is a diameter as shown in the diagram. Now the cylinder has a height of 4 and a radius of 3. What is the length of the shortest path that Adam can take? So let's think about this carefully. In the previous problem, it was a prism and we had to imagine walking along the surface. It says Adam wants to walk along the curved surface of the cylinder. Well, hopefully we can remember the lesson on cylinders where we represented that it's the lateral area, the lateral surface, by imagining cutting the side of the cylinder from like A to down here, cutting that with a pair of scissors, and then unraveling it. And we determined that that shape would be a rectangular shape. So let's represent that shape as so. So again, we're unraveling the curved surface of the shape and making it a 2D problem because 2D problems are much easier to deal with. Now, since we are cutting along this side here, that means like we can imagine our end point is A, or one of these corners is A. Now, unraveling it, what would this opposite end be? Well, it would be basically go around and reach A again, because if we can recall, the length of this rectangle is the circumference of the circle. So usually we would call that like A prime. Well, then where would C be? Well, C is directly across from A, which means it's going to be in the middle of the rectangle. So about like that, where we have C on the top and B on the bottom. Now we know that the height is 4, so like this length here is 4. And now AC, this is not the same AC that we have in the diagram, because remember, we're unraveling the cylinder. The AC actually represents the path from A along the circumference of the circle until it reaches C. So that is what this length here is. It is not the diameter of the cylinder. So how can we find out what the length of that actually is? Well, it's half the circumference since CA is the diameter. So what would the circumference of this circle be? Well, the circumference is equal to 2 pi r, and our radius is 3. So it ends up being just 6 pi. But we don't want the entire circumference, we want half of it since it's traveling along half of the circle. So half of 6 pi is just 3 pi. So now we can figure out the shortest path from A to B along the curved surface would be, again, the straight line represented on this rectangle. And then we have another Pythagorean theorem problem, like we always do. So we have the hypotenuse squared AB squared is equal to the two side lengths AC squared, so that's 3 pi squared, plus 4 squared. which would equal, well, 3 squared is 9. Then we have pi squared plus 16. So what that implies is that AB has the length of the square root of all that. So the square root of 9 pi squared plus 16. And I would say that is enough for us to work with, because we're going to get some crazy irrational number. It's not worth calculating it out. That answer is sufficient. So hopefully we understood that, how that problem worked. If you're not quite sure, I would suggest going back to the lesson on cylinders and seeing how we discovered the lateral area of that in the first place. And one thing to note is the path we found isn't the shortest path the ant could have taken. The shortest path the ant could have taken would just be from going from A to C and then A to B, because that has a length of, well, the radius is 3, so CA is 6 and 4, so that would just have a length of 10. And 10 is definitely less than whatever that number is going to be. But it did say the ant is traveling along the curved surface. It didn't walk along the base. So if you were thinking the whole time, well, why didn't you just go straight across like that? Well, because specifically the ant wants to walk along the curved surface for some reason.